Emerging Trends in IT Industry association with RGPV Bhopal under TechCube 3 on 13th and 14th July. This program is in association with RGPV and OISC. Oriental Institute is accredited by NBA AICT New Delhi. You taking time off your busy schedule to join us today. We hope you will learn a lot today. We have lined up for you to be fruitful and engaging. I welcome our guest of honor, Dr. Ram Kopal Kashyap sir, our director, Dr. KG Sudhakar sir, welcome the coordinator for this event, our honorable HOD Professor Pratik Bujke sir, and co-coordinator, Professor Shadab Khan sir, faculty members and participants. I would like to request Professor Shadab Khan sir to kindly give an introduction about the session.
Thank you, Abhilasha ma'am. Good morning to all of you. First, I would like to request all of you kindly mute yourself because there is so much noise. Yes. Good morning to all of you. I am Shadab Pasha, co-coordinator of this FDP, 2 days FDP, online FDP, on emerging trends in IT industry. As we all know that technology is increasing day by day, and it is very much important to update ourselves. So I think there is so much noise. Now it is okay.
Okay, sir.
Okay. So good morning to all of you. I welcome you all in this online 2 days FDP on emerging trends in IT industry. As we all know that IT technology has many changes now. So keeping this view in mind, we just bring you about the emerging trends in IT industry. And we have 2 sessions, one in the morning, 10 to 12:30 p.m. and another one is 2 to 4 p.m. So I would like to welcome our speaker also and all the participants once again. So kindly hand over to Abhilasha ma'am. Please continue. There's so much noise.
Participants, kindly mute your mic.
Abhilasha ma'am, kindly unmute yourself.
Sir, now am I audible?
Yes, yes.
Okay. Now allow me to briefly introduce you all to our guest and speaker of session 1, Dr. Ram Kopal Kashyap sir. He is working in Amity University, Chhattisgarh, Raipur. He is having more than 13 years of experience. His area of research are digital image processing and machine learning. He has published more than 35 research papers, one international book, and 29 book chapters, among this 13 research papers having index in Scopus. He has reviewed research papers in more than 60 SCI index journals. He is program committee member of the more than 200 international conference. He has received the Best Researcher Award and Student Choice Award. He was invited for stipend meeting at Hindenburg in Germany. Now, I would like to welcome our speaker and request him to start the session. Welcome, sir.
Okay. Thank you so much, ma'am. Am I audible?
Yes, sir, you are audible.
Hello?
Yes, sir, you are audible.
Okay. Okay, thank you so much. Is my screen is visible to all?
No, sir.
Yes, sir.
Yes, sir.
Visible.
Now it's visible.
Okay. So, thank you so much. I'm Ram Kopal Kashyap. So I'm starting the session. Okay. So first of all, you all are aware what is digital image processing, but a quick recap of that. Okay. So why first question is why image processing? Answer is given here to improve the pictorial information. We want to improve the pictorial information. First objective is this. Second one is to automate machine. How we can automate machine we will see in this session. Okay, it's a kind of hands-on session. I will demonstrate something. Okay, and to improve the pictorial information first. Second one is to automate the machine, and third one is for efficient storage and transmission. So why image processing? To improve the pictorial information first, second to improve and automate machines, and third for efficient storage and transmission. How we can improve pictorial information? As you can see in the picture, this is a medical image, and some portion of this is not visible. So with the help of image processing, as you can see in the B and C section, we are improving, and still we can improve with the help of image processing. Now coming to how we can automate machine process by training the machine to detect faces, by recognition of faces. These are the ways by which we can utilize image processing, and we can automate the machines so that machine can automatically detect the person. To automate machine, we can recognize face. Now for efficient storage, okay, for example, we are storing any image and that is a noisy image or blurred image, okay, so it's a useless, it's a wastage of space. So with the help of digital image processing, we can improve the picture quality, and we can efficiently store and transmit the useful and correct images, okay. And other applications of digital image processing is also we can also use image processing for classification of images, and it's a big challenge to combine digital image processing with machine learning. So we can combine image processing and machine learning, and we can classify images, okay. As you can see in this image, there are four kinds of animals are there. So with the help of image processing and machine learning, we can easily classify. At the bottom row you can see tiger and giraffe and deer and elephants are well classified, okay. So these are the applications. And another application is this, okay. We can rotate image, we can process image, we can translate image, we can scale, zoom. These we can do, and it's a very important task of digital image processing. As you can see in the slide, left side image, there is a quality loss, okay. With the help of image processing, with the help of computer program, we can improve the picture quality, as you can see on the right hand side. So and another important application today, we will see this also, okay. It's a very important session. How to track a person. Object tracking is very important, and we can track a person. In this picture you can see many people are walking, and we can track a person, we can track vehicles, we can track any object. So this is the best advantage of digital image processing. We will see this, okay, in hands-on session. Now we are facing a problem in this lockdown, COVID-19, okay, and we want to maintain a distance, we want to maintain a distance. So everyone is trying to implement they are trying to make an application so that they can measure the distance between the person. So here we can demonstrate in this session how we can how machine can identify a gap between the person, and if everything is not up to the mark, alarm and phone calls will be connected. And this is another example of another application of image processing. In this image, in first image, the quality is down, and by processing we can improve the quality. And we are imprinting. We are using two pictures here, as you can see in the screen. One picture, and we are mixing another picture on the first picture. So this is known as image imprinting. Okay, so we are doing this. Okay, we will see this also. And for example, there is a one single image, and this is another image, and we want to perform bitwise operation on these two images, first image and second image, and we will combine together, okay, now like this. So we can perform this. So these are the main applications. Everywhere you can apply digital image processing. Now coming to what is image, digital image. So as you can see on the screen, image can be defined as a two-dimensional function, f of x and y. What is x and y? It's a normal intersection between 2 points, x and y. Okay, as you can see in the slide, values are there: 0, 128, 244. These are the values on that particular location. And 0 means 0. At the bottom you can see 0 is representing black color, and it varies from 0 to 255, and 255 represents white color. So this is a variation in the grayscale image. 0 means absence of all the colors, and value is black, and this is a digital image. So any image we are presenting, we can represent in the form of matrix. So matrix is very important. Now you can see in this example, I am writing a text Ram Gopal, okay, and I am picking the one alphabet A. What is A? A is a combination. How your eyes visualize this A? Because some information is there in A, and these informations are either 0 or 1. Okay, so we are representing those in the form of matrix or array, and we can process these all things. So digital image is nothing but matrix that you studied in the class 10. Okay, so matrix calculation we are doing, and you all are faculty members, so you all are aware what is matrix. So matrix is just a 2 cross 2 row and column. Now, as you can see on the screen, this is digital image, and I am representing this image in the form of matrix. So
Screen is not displaying.
Okay, screen is not visible. I am again sharing. Is it with all?
Yes, sir.
Is it not
screen,
visible?
Kindly present now.
Okay.
Someone, Avinash
So I am
Pant is
again
joining
sharing.
via present now.
Okay, okay.
Participants, you are joining the session via joining link. Do not present now during session.
Okay, so my screen is visible.
No, sir, visible. Visible.
Okay. So here we can see alphabet. Alphabet is a representation of matrices. So we are presenting the 0 alphabets in the form information that is storing in the matrices. Now, as you can see on the screen, this picture, and here representation of pixel. So any information that is missing, that is represented by 0 and 0 to 255. Okay. So what is this 0 and 255? In technical word, we can say this as an intensity. If something is there, that means intensity is there. Okay. For example, 0 means intensity value is 0. Now I am taking an example. This is a sugar cube. You can take a spoon of sugar, and if you are mixing 1 spoon sugar in a tea, then intensity will be very low. If you are mixing 2 spoons of sugar on a tea, then intensity will be high. If you are mixing 10 spoons of sugar cube on tea, then in the high, means it will increase from low to high. So this sweetness level is known as intensity. This is the presence of color. So presence of color, if presence of color is only in 1 spoon, then it will be very light. If you are mixing 2 spoons of color, then color will be dark. Then if you are mixing 250 of color, then you may get a darker image. So this is intensity. So intensity is nothing but presence of color. So if, as you can see in the slide, this is sugar cube, and I am mixing 15 to 20 sugar cubes in a tea, then intensity level will be high. As you can see in this color palette, here if color value is down, that means intensity value is down, means color presence is less. Intensity means color presence. So presence of color is less, and if I am mixing more color, then it is converting into darker images. Okay. So this is about what is digital image. Digital image is a presentation of image in the form of matrix, or you can say in the form of function fxy. And what is intensity? So intensity, in simple words, presence of color. If presence of color is low, then intensity is low. You are mixing only 1 spoon of color, then intensity is low. You are mixing 10 spoons, then intensity is high. If you are mixing 255, then intensity is very high. Okay. Now coming to, I always keep my image, for example. Okay, so this is my image. Okay, this is digital image. So this image is a combination of three colors. So first color is red color, second color is green color, and third color is blue color. So any color image is a combination of red, green, and blue. So if we are mixing 95 spoons of red color and 117 spoons of green color and 48 spoons of blue color, then we get this kind of color. So this gray color, dark green color, we are getting by mixing red color, green color, and blue color. So each color is present from 0 to 255 variations. You can use any combination. Now coming to today's session is a hands-on session. So very soon I will move to that hands-on session also. So this is a color picture representation. Here three channels are there. Any color image you are able to see, that is a result of three colors, red, green, and blue. Whenever we combine these three colors, then we get a color image. So in every channel there is a matrix. For red color there is a some value, and for green color some value is there, blue color some value is there. When we combine these three colors, three matrices, then we get this color image. So this is all about color image. And now coming to black and white image, or you can say not black and white, grayscale color. In black and white everything is black and white, 0 and 1 only. But here we can experience in the earlier black and white TV was there. That was grayscale TV. So as you can see in that slide, color image is a combination of three colors. Red color, here red color is present in 222 intensity value, green color is present in 74 intensity value, and blue color is present in 18. Whenever we mix these three colors, then we get this color, this kind of color. Whenever we mix these three colors in intensity value, then we get this color. Now coming to monochrome or grayscale image, here this intensity varies from 0 to 255, and this is only a variation of 0 and 1, black and white. Here only we are varying black and white. Okay, you are purchasing color, black color from market, and you are trying to mix with white color. For example, 1 spoon of black color and 254 spoon of white color, then you will get a white color. If you are mixing black color in 50% quantity and white color in 50% quality, then you get another color. So this is a variation. Here at the bottom you can see this is a variation of black and white color. It is also available in 255 colors. 0 to 255 means 256 colors are there. Now coming to very important session. I'm not wasting time because time is very important, and we have very limited time. So you all are aware that we can do image processing with MATLAB. But here I will do image processing with Python. Why Python? You all are aware of how we can do image processing with MATLAB, but same feature is free here. So what is the benefit? MATLAB is, I'm not criticizing any software, but I'm giving a fact here. So here in Python, expensive support libraries are there, very rich libraries here, and very important thing, it's a free, it's open source. For this you have to not pay a single rupee, and MATLAB is a commercial software. Okay, same task you can do with the help of Python. And another in Python libraries are there. MATLAB's library are not there, but generic programming facilities are there. Okay, so here we will use Python, core Python, with some libraries like NumPy, Matplot Library, and Pillow is a library. Then we can get better result than MATLAB. Okay. So how we can start? I'm starting from very beginning. Please do it later. I will share PPT also. So here, please open Google. Then here you can type Python download. When you type Anaconda Python download, then you will get a link like this. My screen is visible to all. Sir, my screen is visible?
Yes, sir, it's visible.
Is it visible?
Yes, sir.
Okay, thank you, ma'am. Okay, so whenever you will type Anaconda Python download, then you will get this kind of link. Okay, so please click on that link. Then you will get two versions will be there. So Python 3.7 is the latest version for, so please choose this Python 3.7 version. And after this install, when you will click on this, then you will get the installation window. It's a very simple. Then by simply clicking on next, you will get this, and by agreeing the licensing and terms, and you will get this kind of screen. So here the path will be there, and yes, please here advanced option will be shown on the screen. So please click on this. Please check this add Anaconda to my path variable. If you will not click this option, then every time you have to set path. So please remember this. Otherwise, you have to uninstall your Anaconda. So please check this first option, advanced option. Please check this advanced option, add Anaconda to my path. Okay. And now after clicking on this next button, then you can finish. Okay. Now please go to start menu. Then you will find Anaconda navigator. Once you click on this Anaconda navigator, then what we can see screen like this. Then this kind of screen will be open. Then by clicking on this first option, Jupyter Notebook, you will get a screen like this. Okay, here we will program. So this is a replacement of Matplot. I'm not criticizing any language, but it's open source. That's why I prefer this. Okay, I'm preferring this for hands-on. Okay, so this kind of screen you will get. Quick introduction of this. Okay, so this is a URL. Okay, you will get, and how you can start your programming by clicking on just a new button. New button is there. You have to click on new. Then there will be a notebook option, Python 3. So please choose this Python 3. Okay, once you click on this Python 3, then this kind of editor will be open. Here you have to program each and everything. Okay, so this is your editor, and for how to run this program. So this is a name of program. You can just click on this and you can rename it. Just click on it and you can type whatever name you want to give. For example, DIP day 1 I have typed. Okay, so this file name is DIP day 1, and after that you can simply type. For example, here I am typing x is 35 plus 22 into 2. It will perform addition and multiplication and it will give me result. So this is a simple programming. Okay, there is no need to declare a variable. And if you want to run, then run button is there. Just click on that and you will get the output. Okay, so this is all about this Jupyter Notebook. Okay, so I am starting this in a Jupyter Notebook, how we can perform operation. Okay, so I am moving to Jupyter Notebook. Okay, is my screen is visible to all?
Yes, sir.
Okay.
Yes,
Okay.
sir.
So,
Yes.
okay. Okay. Jupyter is you can see Jupyter written there now. Okay. Okay. So here I am performing x is equals to 35 plus 22 into 2. So what I am doing here I am adding 35 plus 22 and just multiplying by 2, and I am getting the value. I am running this program, clicking on this and run. So I am getting 114 here. So 35 plus 22 is 57. 57 into 2 is 114. Okay, so this is for addition and this is for printing. Okay, now another example, y is equals to, there is no need, just like C. In C and C++, what we have to do, we have to declare integer x, integer y, then float. Okay, nothing is required. And this hash is only for comment. I have written this hash only for your help. So this is not a programming. This is not a part of programming. It's only for quick understanding. Okay, so it's optional. Okay, so y is equals to x minus 13. Here I am performing a subtraction operation. Then z is equals to x divided by 4. I am performing a division operation. So, and z1 is equals to y into z. I want to print this. Okay, so what kind of result I will get? Once I am running this, 114 for value of x. This I subtracted this value by 30. So I am getting 84, and this 84 divided by z value, sorry, x divided by 4, then I am getting 28.5. So this is a simple calculation, math operation, and if you are multiplying y into z, then you are getting this value. Okay, so this is a normal calculation, but we will not waste time because our task is to perform image processing. So this is all about normal processing. So here we have to import numpy. What is numpy? So what is numpy? Do you know what is numpy? So again, I have to move to my slide, okay, because we are using this numpy.
Python library.
Yes, yes, it's very nice. It's a library for package for numerical task. Okay, so if this is not installed, then what you have to do? You have to install it. Okay, so for installing, okay, because it's not installed in your system. So please click on this new button. Then terminal will be there. Okay, one time you have to do terminal. Then once you will click, then this command screen you will get. Here you can type this command pip. PIP is an installation command. PIP install scipy. Yes, then you can install scipy. Okay, if you want to type, if you want to install a numpy, then what you have to do? PIP install numpy. So this is a method. Only single command you have to type. Okay, click on new. Then last option you have to choose terminal. And in terminal, once you are clicking that terminal, then you are getting this kind of editor. Here you have to type pip install numpy. Once you are typing this, then you will get install. So whatever package you want, just click on, just type this package, and you will get installed on your system. So for example, here we will use Matplot library. So I'm installing pip install Matplot library. Okay, and pandas is also there, Pilo is also there. Okay, so what is numpy? So numpy is only for numerical computation. So whenever we deal with the array, because the image is a representation of array, in we can represent image in the form of matrices. So numpy is very important, and numpy is only for array processing. So here image is a array. So that's why we are using a numpy. So numpy, if you are using numpy, then what is the advantage? It gives you faster calculation, high level of mathematics will be there. Okay, and one important thing is, without this, if you are doing same operation in core Python, then it will take 1 to 2 minutes for calculation of a triple loop. And whenever you are using numpy, then it is performing within milliseconds. Okay, so this is advantage. Okay, so for array processing we are using this, for matrices, for images, so many packages are there. Okay, so I am switching over to my screen. Okay, this numpy. Okay, so here, once that is installed on your system, then what you will do, you have to type import numpy as np. So we are importing numpy once it's installed, and we are giving a name, a variable, you can say object np. So whenever we want to use this numpy, then by using np, by calling name np, we can use. So this is we are importing the numpy package, and np.array, and we are creating a array with the help of numpy. How numpy? Because this np is representing the numpy. So npy.array, and we are assigning value 1, 2, 3, and by simply typing a print a, because we are passing this array to a, and we can get this kind of result. Print a is equals to 1, 2, 3. So this is a normal array. Now coming to two-dimensional array, np.array is equals to, inside parentheses you can write 1, 2, 3. This is the first row, and this is second row. So you can separate first row and second row. So this is a simple calculation you can do with the help of numpy. For example, you want to check size of array. For example, np.array is equals to this 6. So there is a one method dot size, a dot size. By size we can get size of array is 6, and shape is a 1 column and 6 rows. So here in this array, 1 column is there and 6 rows are there, are 6 columns, 1 row is there. Okay, so this is a representation. So we are starting after this we are starting our image processing. So import numpy as np.array. We are declaring an array, and variables are 8, 9, 10, and 11, 12, 13. So this is first row and second row. So here you can see 8, 9, 10, and 11, 12, 13. So this is a result. Now after printing, you are getting this kind of result. Now I am reshaping. So reshape function is there. A.reshape, reshape 3, 2. That means you are changing the order. It was 2, 3. 2 rows and 3 columns were there, and you are reshaping three rows and 2 columns. So by this you can use, so it's a replacement of MATLAB, simple as MATLAB. And if you want to find out the maximum value in array, minimum value in array, then you can also use this NumPy, import NumPy as np.array, variables are here, and a.minimum. By a.minimum you can get minimum value is 5. A.maximum value in this array is 10, and you want to perform summation of this, then you a.sum 5 plus 10 plus 22. Okay, sorry, 5 plus 7. 5 plus 7 is 12 plus 10, 22. So 22 you are getting. Okay, so these are values. Okay, so this is all about NumPy. So NumPy is for numerical calculation. You can perform matrix operation. You can rotate. You can reshape. You can crop. Each and every task you can perform with that on the matrix. Okay, just like a computer graphics. Whatever you do in the computer graphics, same you can do here in the NumPy. But we have a limited time. So we are moving to our image processing section. So here I am using Matplot Library. So what is Matplot Library? Matplot Library, why I am using Matplot Library? This is for plotting. Here in image we have to plot bar graph. We have to plot this histogram. So everything is there. So for every task, package is there. NumPy was there for numeric calculation, for array calculation, and here we will perform, once we are performing numerical calculation, array calculation, then we have to plot. Then here I am importing. For your help, I have written comments. So what we are doing, we are importing Matplot library package. So you can simply write import Matplot library, but here inside this Matplot library, one small sub package is there, PyPlot. So here we are again including sub package of Matplot library. So here I am writing from my screen is not visible. Sir, is it visible? I am getting one message.
Visible.
Yes, sir.
My screen is not visible. Okay. So
Yes, sir.
okay. So there may be some issue in anyone's screen. Okay, so my screen is visible. Okay, so here from Matplot library, so we are using Matplot library and importing PyPlot, and PyPlot as
Ram sir.
Yes, sir.
Ram sir, kindly again share this.
No, your screen is not visible.
Yes,
Okay, sir. Sure. Okay.
Participants, kindly join now. This using join now button. Join every session. Do not present now during session. Otherwise, session will be great or interrupting the expert.
Now my screen is visible.
Yes, sir. Now visible.
Okay. So here what we are doing, we are using sub package of Matplot library. Matplot library is a package just like NumPy, and inside that one dedicated package is there for Python plot. So this is PyPlot. So this is a way to add package from Matplot library, import PyPlot. PyPlot is there as PLT. So as PLT is the name of object by which we can call this all the features of PyPlot. So this is a syntax. By this syntax, what we are doing, we are importing the Matplot library and PyPlot. So here I am making an array on list. You can say x is equals to 5, 2, 7. So this is a value for x, and this is a value for y is equals to 2, 16, 4, and simply these two values are there. So I am using PLT. What is PLT? PLT is an object. So with the help of this, I have to plot. So PLT.plot. Inside this PLT means PyPlot, plot function is there. So PLT is representing PyPlot. I'm calling PLT.plot. Then I'm passing value x and y. Then I will plot this x and y value. Okay. So this is a representation. So once you want to get this kind of figure or diagram or plots, then you have to use Matplot library. Again, you want to give some title, just like a MATLAB. So here PLT.title is equals to info. So here we have given info as a title of this figure or chart, and you have to also assign x value and y value. So PLT.y label is equals to y axis. So here we are giving y axis, PLT.y axis. and same for x-axis. Okay, so this is a very simple method. Okay, by writing code of 6 to 7 lines, you can replace MATLAB. So here we are not replacing MATLAB. We are only explaining the feature that is freely available. That is Jupyter. That is Python. You can explore. Why you are wasting money 5 lakh, 6 lakh rupees per system or for 5 systems. Okay, so this is a replacement. Now coming to image processing. So one by one we are moving ahead. So this is again next solution from Matplot Library. Import PyPlot as PLT. So here we are doing same. We are importing Matplot Library and we are using subplot sub package of this PyPlot. And here we have to plot bar. So PLT dot bar and values are this 0.25. What is this 0.25, 1.25, 2.25? This is location. This is just like a indication. So your scale, this is scale and this is value. So this is a scale. In this location, 0.25 location, value will be 50. 0.125 location on the scale, value will be 40. I'm demonstrating you. So this is 0.25. This is 0.25. This is 0. This is 0.25. So 0.25 location, value will be 50. And this is 0.11. Here value will be this 40, 1.25. Okay, so these are the scales. So here we are giving location, scale and value. On which location? This is scale 0 to 5 you can take. Okay, I am taking 0.25. Here 0.25 value will be 50 and label I am assigning BMW and width is a 0.5. Why 0.5? Because it will take 0.5 space. Okay, 0.5 space. Okay, I can reduce this. Okay, for example, I am reducing this 0.1. Then you can get smaller width. Smaller. This is width is reduced 0.1. So I was keeping it 0.5. You can keep it 0.2 also. Here in red screen you can see width is 0.5. So it's up to you. Okay, but by scaling, if you are scaling now, then please consider this also. Okay, you can reduce width by 0.2, then run. Then yes, red bars you can see width is just double to this. Okay, so this is a width. Okay, so n number of features are available. So this is these are the scale on this location. Value will be this. So 0.75 is a scale on 0.75. This is 0.75 and value will be this 80. So this is a value. Okay. Now if you want to assign a label, then label is equals to OD, color is equals to red, or width is equals to 0.25. Legend X label, you can assign label to X. This is X label days and Y label distance. Okay, so this is a X label days and Y label distance. And the title you can assign information and plt.show. This will display your figure. Okay, so this is all about how to draw a bar. And one last exercise, histogram. Then we will move to our image processing. Pure image processing. We are doing image processing. We are processing array. We are plotting. These all are also part of image processing. So we are, since morning we are in the image processing module. But all these things are required when you will process image, because you have to represent your image. So if you are not having an idea how to label, how to give a title, someone is also presenting, I think. So my screen is visible again.
Yes, sir. Yes, sir. No.
Yes, sir, it's visible. I request all the participants to kindly mute yourself. Mr. Ahmed, sir, kindly mute yourself.
Okay, so shall I continue?
But just a minute. Mr. Ahmed, sir, kindly mute yourself.
It's not visible, sir.
Okay, okay. So again, I'm repeating same process. Okay. Okay. Now my screen is visible, I think. Okay. Now it's visible.
Yes, sir, it's visible now.
Yeah.
Okay. So population is value 55 values, and and this is another value. Two values are there, one value and second values. Okay, and we have to plot a histogram. Then plt.hist is there, and we have to pass value population A's, comma bins. I'm getting noise. Everyone, please mute mic. So these two values I am putting here: population A's and bins. So am I audible? Everyone, am I audible?
Yes, sir.
Yes, sir.
Okay, okay. So here I am passing population A's and bins, and histogram type is there. Okay, you can select type and width. Okay, so this is a label, as you all know, and a Y label. Once I'm running this program, then this kind of label image I will get. Okay, so this is histogram. Histogram is very important. It will help you to identify darkness and brightness. How one image is dark and how many pixels are there. So this part represents darker side. Okay, this parts represent darker sides, and this part represents brighter side. The value is from 0 to 128 represents darker side. Okay, so you can say see here bars are very less, then your image is a bright. So this is a bright image. Okay, so sometimes we do good. So we balance these histograms. Okay, we mix black and white. Okay, so we will see this. Okay, so now very important thing, I'm starting this image processing. So these all are very important. Now I'm performing another operation: import Matplot Library .pylab as a PLT, and I am reading image. Yes, so this is first image processing. Earlier we were doing on processing on the data, that is also part of image. Here I am giving a path. Here I am giving a path C colon users. So one folder I created in the desktop, DIP, and inside DIP, inside desktop, folder name is DIP, and image name is rgk.jpg. So what I am doing, I am giving that path here. So for path, I just copied the desktop location and folder location, and with extension I have given the path. Here, why I am writing R? Why I am writing R? So yes, without R, if I am trying to run my program, then it will give me error, Unicode space error. Okay, yes. So I want to avoid that error. That's why I am writing R. Here description I have written R converts string to raw string. Okay. For example, if any space is there, any backspace and forward space is there, then it will consider each and everything. You are writing R and there will be no ambiguity. It will consider that string as a raw string. Okay, clear? That converts that string, whatever the path you are giving, that will be considered as a raw string. That's why we are giving raw. So if without this, if you will run, then you may get some error. Okay, we are not understanding your path, and some slash, forward slash is there, backward slash is there, confusion is there. Someone is writing path inside a single quote, someone is writing inside double quote. So there are a number of ambiguities are there. Okay, so to avoid this kind of ambiguity, just put R and PLT. PLT is a object of this Matplot library, and we are using that PLT.imRead. So this function will read this image available in this path, and this will read, and this will store inside the IM. And whenever I use this PLT.im show, then I will show, this will show me the figure. So this figure was there. This figure was there. This is the output. rgk.jpg was there. Okay, so this is a figure that was stored inside this desktop DIP folder. So by using IM read, I can read the image, and I'm storing inside IM, and you can store inside any variable. Okay, and the plt.im show, whatever variable you are using, you have to pass here. So this is the first program, how to read and how to show your image. So this is a very important. Okay, so here we are using plot library, PLT inside PLT package, PLT plot pylab, IM read and IM show are there. Okay, now coming to another exercise. Now I want to check that matrices, because I have shown earlier a picture is a combination of values, intensity values. I have given a lecture on intensity value. Intensity value is the presence of color. So this, by using print im is a variable. Inside that we store the value. Okay, you can choose any variable. Print im. Once I am writing this will print the values. So this is printing red value, green value, and blue value. Okay. So 255 value you are getting, 253 value you are getting. So these all are values. N number of values are there. Many values are there. It depends on the pixel resolution. Okay. So this is a representation of your image. So your image is a matrix, a big matrix, matrix of 2000 columns will be there. Okay, you perform a matrix operation on 3 cross 3. So you can see this. It's not useless for you. Only for observation you can say print IM. Okay, because many pixels are there, many values are there. Now display, by using display function you can display the picture. Okay, now you can extract single color also. So to extract single color, just put colon and this. So it will give you a single color image matrix. Okay, so image is a combination of 3 colors, red, green, and blue. So you can get this uh, one channel, you can say. Okay, yes. Now I want to convert this show by using plt.im show. I can show my image, but there are color maps are also there. So color map, for example, color map is there cool. So once I'm choosing this image with color map pool, then I'm getting this kind of image. So these are available. Color map also, different color map is there. If you want to represent your image in different form, so plt.im show I am one. In the place of cool, you can write also hot. So hot color map you are getting. You can write pink here, you can write gray here. Whatever color map you will assign, color will be converted. Okay, for example, I want to display gray. This was color image, but I want to use color map gray color, then I am using color. If you want to use color pink, then just click pink and run. Yes, pink kind of image you will say get where it is. Okay. Okay. Yes. Okay. Image converted. Okay. So pink is also there, gray is also there. Okay. Okay. Now coming to another program. Okay. So yes, here what I am doing, I am processing. I am doing the image processing. Okay. For that I am using Matplot Library, PyPlot, and PLT I am using. Okay. Inside this, just like PyPlot, just like PyPlot, sub package is also there. Image. So again, I am importing. These are comments. It's up to you. I have written these comments only for your simple understanding purpose. Okay, it is helping you. Okay, you can remove these comments. Whatever you are writing inside hash, you can remove. Okay, these are your codes: 1 line, 2 line, 3 line, 4 line, and 5 lines. Okay, and these are only for help, just like C++ comments. Okay, so import Matplot library library.image. Image is a sub package, and as RIM. I have given R image. Okay, and you want to get your output on the screen. That's why I have written Matplot library inline. Otherwise, you can get a new window will be open. Okay, new window will be open. Okay, we will see in this program, in this exercise, a new window will appear. Okay, will also appear. But we have wanted output here. That's why I have written Matplot library inline. If you will not write this now, then it will be displayed on the new window. Okay, so again, what I am doing, I am importing. I am read, and this is the location RGK image I am importing, and RIM is a variable. Okay, of image sub package, and I am storing in the image, and same task I am doing whatever I was doing earlier. Okay, but it's with the help of image. Okay, now you can see this image. Here you can see axis is also here. Axis is here 0, 200, 400, 600, 800. These are axis. So I want to remove this axis. So what I have to do, plt.axis and off value. I have to give, once I have written this off value, then plt.imshow.image inside parenthesis image. Then this axis will remove. Okay. So and you can save this image also. Okay. So this is an example. You can do image processing on these images. Okay. Axis off. Axis on, you can do axis on, axis off. Okay, so these are the syntax. Now another package. Yes, so n number of packages are there. Many different kind of operation you can do. For example, numpy package was there, matplot library was there, and now another package that is dedicated for image processing, pure image processing. Another package is pillow, PILLOW. So I am using that package. So from PIL representing Pillow package. So PIL import image. So inside this PIL also image package is there. Image sub package is there. Earlier in this operation, I was using Matplot library, and my Matplot library image package was there. Same task you can do with the help of Matplot library, but limited features are there. But I want to do advanced image processing now. Then I have to choose these Pillow, because this Pillow is having more features than Matplot library. So I am moving ahead. Later you can explore also TensorFlow, Keras. These are new packages. You want to perform neural network, then you can go do. You can include these packages also, just like that. Because I was doing here basic image processing, so I was using Matplot library. That was showing my figures, bar, histogram, everything. That was sufficient. I can still do, but I want to do advanced processing. So here package is there, then I have to use from PIL. PIL represents Pillow import image. Image is a sub package. Now with the help of this image.open, now syntax is changed. Image.open. Earlier we were using imread, but here Pillow we are using open, and path is same. So we are reading this image and we are storing inside RImage1. RImage1, I have given a name RImage1. And I want to rotate. I want to perform computer graphics task. So here I am using RImage.rotate. Rotate minus 50 degree. Minus 50. Why I am writing minus 50? Because minus, whenever you want to move inside clockwise direction, in the clockwise direction, then you have to put minus value here. Okay. For a anti-clockwise direction, you can put normal value. Okay. Here we are moving in the minus clockwise. That's why. Yes. Now here in Matplot library, you were able to see output on the same screen. But once I will run this program now, then new window will appear. So rotated. I am here using rotate. I am taking this image, rotate minus 50 degree, and rotated image dot show. I am running this. I am not getting this output there, but new window is here. You can see my screen. You can see rotated is image. Everyone, is it visible?
Yes, sir. Yes, sir. Properly.
Yes. So yes. So this is a rotation. You can perform rotation operation. Okay. You can do this minus 180, 170. So you can see. So in the next window, yes, this is a rotation. So everything is there. Many packages are there, and you have to explore those packages only. And I want to rotate transpose. Transpose is also there. Rotate, just like a rotate transpose is there. So transport, I have to give a direct angle, 90 degree, 180 degree. In your image editing software, 90 degree, 180 is there. So it will directly converting it into 180 degrees. Okay. So this is all about basic image processing, advanced image processing, you can say. Now we are coming to research-oriented studies. In research-oriented studies, what you have to do, you have to find out the image ages are using not. Someone is doing thesis, master's thesis, PhD thesis. So for that, we are doing image processing. So from PIL, means the PIL Pillow library is there, Pillow package is there. We are importing image, and inside that we are using filter. So filter sub package is also there. So I have to import also PIL import image filter. Image filter is a sub package inside the Pillow package, and I am also using Matplot library. You can mix many packages. Okay, whatever you want to mix, you can mix. Okay, you can use NumPy also. You can use NumPy, but only one variable is required, TLT. If you want to use Matplot library, then TLT. You can give any name. Here I have given TLT name, NP name, image and subpackage, image filter subpackages we are using. So here what I am doing, I am reading a package. I am opening a image, and image is stored inside desktop. The IP folder is there, Lena.jpg, most popular object in image processing, Lena. Okay, Lena.jpg. Okay, so image.open, then it will open the image and restore it here. Then what I am doing, I am performing this image.filter. I am applying filter. What kind of filter? Image filter.find edges. So this is available inside find filter, image filter sub package. So I am just writing code, image filter.find edges, and yes, these I have to store in the form of array, because if I will not convert this in the form of array, na, then it will sometimes it may give me error. So that's why I'm using a numpy. Numpy.is array. Whatever output I'm getting, image with edges. This is a variable I'm copying here and pasting here. Okay, but I'm treating as array because sometimes it may give error. That's why I'm writing this. Okay, so image is also a type of array, and I'm storing this value inside IM, and I'm printing IM. I'm running this program. Okay, once I'm running this program, then what I'm getting, this age I'm getting. So this is the age. So by simply using the filter, any number of filters are there. Median filter is there, main filter is there, and many tutorials are there. You have to explore. You have to, in the place of this, you have to write any another filter name. Okay, find edges in the place of this. Find edges, you can write medium. Okay, so this is the age detection. Canny is there, Sobel is there, Privet is there. So this is age detection. Okay, this is converting. This is giving you age. Why we why we work on ages? Because ages are very important. Because someone is having a tumor, then how you can identify tumor? So some circle will be there, some contour will be there, object will be there. So brain tumor is something there on the brain, and that have some space, that is capturing some space, and you want to get that with the help of MRI scan or CT scan. So you will get a picture. What is X-ray? X-ray is a representation of your image, a bone's representation. Okay, and if bone is broken, then there will be two. In the place of one bone, there will be two bones. Okay, so by the help of what is there inside the body or inside the picture. Okay, now another example from PIL import image. I am importing this PIL pillow, and image is a sub package. Image filter, I am again importing sub package, and Matplot Library, PyPlot, NumPy. Okay, I'm opening the image that is stored here. Yes, now I want to sharp. Yes, sharp. I have to sharp. Then in image filter, I'm writing image.filter. Then image filter.sharpen. Sharpen is a code for sharpening the image. So once I'm doing this and I'm converting this in the form of array. So as array is there, and I'm putting this value, and I will get a sharpen image once I will display this IM1. But I am a clever, because I want to again sharp it. Then again whatever value I am getting in IM1, I will again sharp. I will again sharp this image. So n number of times you can do, n number of processes you can do, again and again you can call. And you want to subplot, you want to plot. Okay, so how you will plot? Subplot function is there, subplot. And what this is representing? 2 is representing 2. In subplot, you want to see those two images in a single place. So this is a 2 is representing rows. So in subplot you want two rows, one column, and in one column first value will be this. First value will be this image, and second value will be this image. Okay, so I'm running this program. I'm running this. Okay. So here you can see, yes, here you can see two images. You can see two images. Okay. So this is with the help of subplot we can do, and these are inside of one column, and two rows are there. So let me check. Yes, one column. In the place of column, one is there, and this is representing row. So row, two rows are there, and one column is there. And first display this image, then second display this image. Okay. So this second one is a sharpen image. Sharpen means you are sharpening the image. You are giving edges, extra edges. You are giving extra edges. So here you can get this is original image, and you are giving sharpness. Sharpening means some edges you are, some finding, some corners you are getting. So many corners you are getting. Okay. So this is a function subplot. With the help of subplot, you can easily plot, and this is represented in two rows you want. For example, I am changing this two rows and two columns. So I am giving two columns and two columns. So let me check. So it is converting two columns. Okay, but only two values are there. So I can replace one and one row and two columns. So it is representing one column or one row and two columns. So you can get image one row and two columns are there. And first value is this, index is 1 and index is 2. So is it clear? So this is a representation subplot. Okay, you can create many rows, many columns. So remember this is for row, this is for column, this is for index. Index number 1, 3, 4, 5. Okay. Now coming to another image processing. Yes, as you know who is he? South Indian villain, I think. So I'm getting his picture, okay, for this processing task, okay. So yes, so this morning we have used NumPy, Matplot Library, then Pillow, okay. Now everything, every package has their advantages and drawbacks, okay. Many things are there, okay. So whatever you are doing in Pillow, you can do with the help of Matplot Library. But in Pillow, single line command is there, but in Matplot Library, 3 lines you have to write. Okay. Now new package is there, computer vision, because our task is to detect tracking. In this session, we will track the person, we will track car. So I am using a new package. So here I am using, because time is very limited. Sir told me please cover within 2 hours all the aspects of digital image processing. So I want to give glimpse of each and every package, what is there and what is the beauty of that. So another package is there, CV2. What is CV2? Import CV2. CV2 represents computer vision. It's correct. But what is 2? 2 is a version name. Version name is 2. Yes, because that means before CV2 there was a CV was there, but functions were limited. So it's an advanced version of computer vision 2. Yes, it is also very well equipped with camera tracking devices, sensors. If you are performing this same operation in CV, then you have to write 5 lines of code. But you are using CV2, then you can do same task within 1 line. Okay, so this is a package CV2. That's why I'm writing import CV2. Now import NumPy. Again, I am using NumPy. Again, I am using Matplot Library. Same task I was doing in the Matplot Library. Same task I was doing in the Pillow. Same task I am doing in computer vision. Okay. CV2. Earlier I was using PLT. Earlier I was using image. Here I am using CV2 because I am performing operation on CV2. Only difference is this. So CV2 dot I am read, and I am reading this image a.jpg, that is stored inside the IP in folder on the desktop, and I am storing these values. Okay. Can you see my screen? Yes. Okay. Is it visible? Hello? Yeah, okay.
Yes, sir.
So this is I.
Yes, sir. It's visible.
Okay, thank you so much. So I am reading this image, okay, and I am storing inside image, and same I am doing access of. So access of is a PLT. PLT means the package of this Matplot library. With the help of this, I am doing access of PLT.IM show means Matplot library is helping me in access of I am showing. Okay, so I am doing these operations and I am showing. And CV2, yes, inside CV2 blur operation is there. So I want to blur my image. So what is the advantage of blurring? If you are doing a blur operation, if you are performing a blurring operation and the window size is 7,7, so you will get this, you are putting this image IMG and 7,7 is a value, smaller value you are taking, okay, and you are blurring and you are storing this inside the blur, okay, and you want to show. And this is a subplot, one row, 2 columns are there, and these are just like an array, like a presentation. Okay, so I'm running this program. Okay, I'm running this code. Yes, now you can see this was my original picture. Now see the application by blurring how my original picture converted into this smooth. So this is a smooth operation. Smoothing I have done earlier. I was doing the sharpening. In sharpening, what I was doing, I was including extra edges. I was adding some edges on the corner. Here I am removing edges. So this is a sharpening operation. Okay, so this is a blur operation. So I perform. How I perform? By simple writing cv2.blur, cv2.blur, and I have given size. Okay, so this is a You can convert, you can use these colors, everything is there, okay. Without this you can also do, and there is no need to write x dot ticks, okay. If you are getting any kind of problem in display, I like display, you are not getting output, then you can write plt dot x ticks, otherwise it's not required, okay. You can write only plt dot show, I am show subplot, okay. You can give a title was original, title was smooth, here we have given title original, here we have given smooth, okay. So this is all about computer vision processing. Now moving ahead, because our objective is very challenging, we have to do tracking, and here we have done sharpening, smoothing, rotation, array-like representation, everything we have done, okay. Now I'm importing this image plus computer vision package, then NumPy package. NumPy for only array processing, okay? Because array is a image is an array. Sometimes you may get error. That's why we are including this. Matplot library is a PLT, and I am opening this path. Path is this. I'm opening this. I am read. Now, yes, very important. Create an image of it. We did this, okay? Now this function is there. This function is there inside computer vision. What is the role of this function? This function is used for image denoising. So you want to perform denoise operation. If you want to explore more, then just type this and type on Google, because time is very limited. We don't have very much time, because image processing for image processing one day is not sufficient, okay, and I have to cover many more topics within 2 hours. So these are parameters, okay. So this is a function inside CV2. Fast and L means denoising colored function is there, and these are the parameters. I am passing image, and some parameters are also there. None, value, window size, for example 10, 10, 7, 21, okay. So these are parameters. You can explore more by just typing this, okay. So what this function will do, this function will take this image, and these are some parameters, okay, and this will convert my image into denoising image, and I'm storing inside DST and plt.subplot. Location is a 1, 2, 1, or you can either write 1 to 1. So 1 is a row, 2 is a column, and first value is this original image. Original image was this. I'm passing original image, and the converted image I am passing here. Let's run this program. So once I am running this program, then yes, so I am getting this kind of image. So this is a denoising. You can see how handsome he is looking. Earlier in this image, many wrinkles were there, and distortion were there on the face, okay. So for your yes, can you easily identify by denoising how I can reduce noise? In the first image is a full with noise, and second image is a clear. So this is an effect you can do with the help of Photoshop. But how Photoshop is performing? By once we are implementing in some language, then only those implementation Photoshop is copying. Okay, so researchers are developing these functions. You can modify these filters. Now let me take another image. Okay, so I'm taking another image. Okay, and I'm running. Yes, now you see the difference. Now by denoising, and now see phase difference. Okay, so this is the effect. This is a image processing. So you can visualize what the power is inside in the code. So this we can do with the help of only 6 to 7 lines of code, nothing else. So it's a very important. Okay, you can develop. So are you able to identify the difference between two images? Is it visible, everyone?
Yes, sir.
Yes. So this is the role of sharpening, deblurring. So only we are using here denoising. Okay. So this is the beauty of denoising. Okay. Now coming to another example. Okay. Another example. Yes. Now yes. Here we have to perform. Time is very limited. Okay. Okay. So here, you all know what is object tracking. Tracking is the application of image processing. Okay, So once you want to track any person, video surveillance. In video surveillance, what we are doing, we are observing any person. For example, you experience any person is there, any criminal is there, and you want to observe that. So for that, you have to do object tracking. It's a very important research topic. Okay. So here we are doing object tracking. So I will do this in 6 to 7 lines, 10 lines. Okay, it's a very important. Okay, so here import numpy as np. We are using import numpy as np. This is numpy package. Some features, for some features you can use this numpy. Another is import CV2. What is CV2? CV2 is a computer vision 2. So computer vision 2 we are using. Now coming to next time. So cap is a variable, and here CV2 dot video capture. So video capture is a function inside the CV2. So once you want to capture the video, that is stored inside your computer, then you have to give video capture. Okay. So by writing this video capture, what you can do, this video is stored inside DIP folder on the desktop, and name of the video is vtest.avi. So I am giving the path of this video. Okay. So this is a path, and I am capturing with the help of computer vision 2, and I am storing inside cap variable. So this is just like an image processing. In the earlier image, what we were doing, cv2 dot read cv dot I am read. So that was for image. I am for image read. And here we are doing video capture. So video capture is here. Okay. Now again, capture the video capture from the given path. Okay. Now there is a one method. You can design your own method also. Okay. But Gaussian mixture based background segmentation method is there. So Gaussian mixture based segmentation method is there. So I want to use that method. So that method is here inside create background subtractor mog2. This is a function name that using the method Gaussian mixture based background segmentation method. Okay. So once I want to use that method, so I am giving the name of that method. Okay. As a researcher, you can design your own method and you can give function like this. Okay. And anyone can use those methods. Okay. You can publish those methods. Okay. So you can modify, you can improve. If anything is missing in segmentation, then you can improve the performance. Okay. And I'm storing this inside fg foreground background. Okay. This is a variable. Now what I'm doing, so by these two lines, it's clear. I captured a video, and I am using Gaussian mixture function to subtract the background. Now coming to next. Here, while one condition is always true. Okay. While loop, I am writing yes. ret and frame is equals to capture dot read. Whatever I captured, I want to read. Video I captured and I stored inside cap variable, and I want to read. Okay, and I'm giving that video inside the loop. Means video will run till any break is not there. That means I want that video unstoppable. Okay. That I kept this true. One means condition something value, I have given value true. Cap.read. So I'm reading those videos. And inside this, what I'm reading? I'm reading RET and frame. So what is RET? RET is a Boolean variable that returns true. So this RET value is what this is doing. This is returning you 0 or 1. 0 means video is not coming, and 1 means video is coming. So this value is giving you alert that video is coming or not, because after some time, after 5 minutes of video, after 10 minutes of video, your video will end. Then it will give you 0 value. No? Then you will not get any written value 0. Okay. So this is an indication your video is running or not. So this RET will give you value. This is observing video is coming or not. Just like fan is rotating or not. Car is moving, vehicle is wheel is moving or not. Just like that. Okay. So 0 or 1 value it will return. Okay. And what is frame? Okay, frame. Yes, frame is an image array. So you all know video is a combination of images. So video is a combination of images means what is video? Video is an image array. So you want to capture those inside the frame. So for example, you are capturing image and frame size is 30. So 30 frames in a given second. 1 second, within 1 second, you can capture 30 frames. Your human eye can also read anything. Your human eye also can recognize any object if it is visible. Yes, I think someone is presenting. So my screen is visible to. So
Yes,
my
sir.
screen is visible to.
Yes, sir.
Okay. So again I have to. Okay. Again I am sharing. Okay. Now is it visible? Now is it
Yes, sir.
visible? Okay.
Yes, sir.
So
Yes, sir, it's
so
visible.
oh, okay. Thank you so much. So inside frame, we are storing number of frames. Whatever images we are getting now, we are capturing those frames and we are storing in the frame. Okay. So these values we are getting from the video. So we are extracting the value video is coming or not, and whatever video is coming, we are storing inside the frame. So now coming to next. Now here we are getting the stored video dot apply is a function. Apply is a function inside the computer vision. So here by applying this, what we are doing, we are applying the mask. What is mask? Mask is just a image, a rectangle kind of structure we are applying. Okay, a rectangle kind of image we are applying on the frame. So size of frame we are keeping same. So we are applying mask on the frame. Whatever frame we are capturing, we are applying. This is a complete image, foreground, background we extracted. Okay, earlier you can see here, we stored inside this, whatever we captured background, we stored here. Then we gave this inside the loop, and this video we are giving, and on this video we are applying and we are giving the frame. So this, what this line is doing, this is applying the mask on the background. So this is applying the mask. One mask is there, okay, and this mask value we are storing inside the FG mask, okay, foreground mask, okay. So let us understand this mask value. Mask value we are getting just we get the value video is coming or not by returning values, returning and a frame by frame we are reading each and every frame, and each and every frame we can store. I will demonstrate. Okay, each and every frame we can store inside the computer. Okay, so this is also a part, and each frame we are giving. For first frame we are applying, then second frame, third frame. Okay, because we are giving this inside the loop. Okay, because in the loop you have to run now for first candidate, for second candidate, for third. Now we applied mask. Now I want to show. This FG mask I want to show, and I want to show frame. So mask and frame both I want to show in a same image. So I will show, and here I have given a parameter. So k is equals to cv2 dot key 30. So this 30, what is 30? 30 is a seconds, milliseconds. Okay, so 0 means a quick response, faster, just like a forward means it will increase the speed. Okay, motion speed is, it will increase. So normally we are giving it 30, and if you want slow frames, then you can give 60 frames, 100 frames. So slow motion video, as you can see in your camera, slow motion video recording is also there. So what do you mean by that slow motion? Slow motion feature is also there in your mobile phone. That means slow motion means value of this millisecond is high. Millisecond maybe 70, millisecond maybe 200. Okay, so here I am keeping a normal value, that is 30. 30 frames we can observe, human eyes can observe. And this is the delay, just delay. Okay, if k is 27, yes, this video will run, and this is because we are working here, okay, and this is and I want to stop. Then I am also programming for skip. Skip button is there on the keyboard, and that value is 27. 27 value is there. So once you are pressing skip button, then it will break. It will break your video. Okay. So this is a code. Now let me run this code. Okay. And sometimes it may give error. Okay. Yes. Now you can see my screen. Yes. You can see my screen.
Yes, sir.
Everyone. Yes. So this is a video. This is a video we are representing in the frame. Yes, this is a video. This is a video we want to observe. And backside, yes, we were performing a subtraction. So yes, this is a tracking. We are removing unimportant things, and we are identifying how persons are moving. Okay. So in this program, I want to capture each and every one, and every useless thing is not shown here. Okay. So is it visible, everyone?
Yes, sir.
Yes, sir.
Okay. So this is a okay. Okay. Sometimes it gives error. Okay, because it takes too much frames now. And okay. So it is all about this frame. So you, as you can see in this example. Okay. Two windows we are okay. So this is a tracking. Okay. This is a tracking. Okay. Okay. Sorry. There is a code I have to open. Yes, this one. Because it takes too much frame now, so it disturbs the settings also, because it opens so many frames, because we are tracking and it so yes. Now another example. Now in COVID you want to measure the depth. So people are maintaining social distance or not. Yes. Yes, my screen is visible.
Yes, sir.
Okay.
Visible.
So yes. Second program I will explain this. Okay, this is also a program. So you want to check pupils are maintaining the social distancing or not. So if any depth is there, when so many pixels are there and gap is not there, then you can put a message. You can put an alarm in video surveillance system also. Not everything is not proper. As you can see on the screen, persons are moving, but distance is not uh, uh, too far. Okay, so they are not maintaining a distance. Okay, so this is all about your object tracking, and you can also resolve accident. Okay, if two vehicles are coming and they are clashing, then accident is there. Okay, so these all are example of object tracking. Okay, so it's a very important concept. Okay, and we can do object tracking, and how many lines we have to code? Only 10 to 15 lines we are coding to read these video tracking and all those things. Okay, so this is all about video tracking. And now coming to this program, next program, this I explained. Yes, this COVID-19. Okay, so here again I am also importing computer vision 2 package. Okay, and numpy, I am capturing the video, I am reading the frames, and I am storing, I am getting value is which video is coming or not, and I am storing inside the frame 1. Okay, here because for density checking, hue, saturation, and value, one color model is there. So I have to convert my video into that color format. So I am converting this my RGB color model to gray color model. Okay, so this is a color code. This is a code CV2 color change for frame 1, CV2 dot color. This is for just conversion, one color medium RGB to grayscale, just like that you're converting into gray. Now yes, here I am using a zeros, like one array I am keeping, and in that array I am putting every value 255. So for this means I am putting first column as 255. Okay, this is a technique. Now after that, same task I am doing. I'm reading the video. I'm checking is video is coming or not. If value is coming 0, that means video is not coming. If value is coming 1, that means video is coming. Frame I'm storing. I'm converting those images into gray. BGR, red, green, blue to gray. Okay, image to gray. Then I am performing optical flow. Optical flow is a function, okay, given by this uh, Back algorithm. Okay, Back algorithm. So Back is a name of person who has developed this optical flow. Optical flow is of measuring person density where person is going. Okay, so this is a function you can just call, and these are the parameters. I have given description of these parameters at the bottom. Yes, what is the role of this previous, what is next flow, you can read, because in a given time slots it's a very difficult to cover previous, next, everything. Okay, so many parameters are there, so I'm demonstrating you this function. Okay, and so many parameters are there, and just do this thing. Okay, just copy this and paste on Google. You may get each and everything very clear, and after some time you can develop your own method also. You can improve these methods, and you can do a research. You can write research papers on those topics. So this is a flow, optical flow, and we are storing inside the flow. Then yes, card to polar. Yes, this value polar is a medium. Just like that in this video you were saying faded color we were saying faded color, rather than single object we are getting a faded color. So this is a conversion from card to polar. Polar we are converting. Polar is a spreaded color, okay, in the form of spreaded. Okay, yes, color is spreaded, as you can see in this picture. Okay, so we are observing this is a polar medium. Okay, so we converted this from card to polar medium. Okay, then after this yes, and polar medium angle magnitude, where direction to identify the direction where these vectors are moving, where they are going. So we are capturing this inside the HSV value. Angle 180 we are keeping, and this is a calculation. Okay, so you can easily explore, you can type and explore. Okay, so I'm explaining this is converting Cartesian into range 2 pi 180 degree. We are taking Q value. Then normalization, we are doing normalization, and by doing normalization, what we are doing, we are getting minimum value, and we are displaying the HSV color model. Okay, and we are displaying this HSV model here, and same code we are writing here. Okay, so once I'm doing this weight key 3, then you can see speed will be faster. Okay, speed is faster than previous one. Okay, clear? So this is a weight key. Okay, so milliseconds, we are giving milliseconds. Okay, so this is all about video tracking. Okay, video tracking. Okay, and close all. You can display. I will share these codes with you for your practice. Okay, and the PPT also. And now coming to some other aspects of image processing. So here we are doing we were doing object tracking. We have done object tracking. We are also identified density. We tracked. Now I want to do histogram equalization. So I am reading image arrow 3 is a name of the image that is stored inside DIP, and I am reading that image. And I am converting. Yes, I am storing this inside IMG. Now I want to perform histogram equalization. So histogram equalization also give you better image, because in some images you may see some portion is darker and some is lighter. Okay, so you want to balance those images, so you will take average. So half portion is darker and half is brighter, so you want to balance those pixels. So for that purpose we are doing equalization of histogram. So here I am doing equalization, equalize histogram. So this is a function equalize histo, and I am passing this value here, image, and this will give me the equalized value, and I am storing this value in the stack, because sometimes I may get error. That's why I'm using a array processor also. Numpy np.hstack I'm using function. It will store my images step by step, pixel step by step. I'm passing image and equalization. Okay, and now coming to I am I am storing this inside the res.png. You can store function. You can store your output as a I am right. Once you are writing I am right, then it will store. It will write, and you can give any name. Any name. Res. I have given. You can give A, B, C, whatever you want to give. Okay, and this is a name you want to display at the top. Now I want to show, and the showing you can give any name and wait key. Okay, so I am running. Yes, here you can see on the screen two pictures are there. So first picture is a normal arrow picture, AERO arrow 3 picture is there. Here you can see some portion are bright and some are dark, but it's not clearly visible. So at the right hand side, what we did is we performed a histogram equalization, and that histogram equalization is balancing the color. And now you can see at the right hand side, same picture is visible, and its quality is good. So this is a balancing of intensity values. All pixels were there in the image, but that was not in the form of presentable form. So we perform histogram equalization. So many times we perform this histogram equalization operation to improve the quality of image. Okay, and this is the name of function RAM. I gave the name RAM. I gave the name of this one. So this is a yes RAM. You can give any name. RGK, okay, for example. Okay, so this is only representation for your purpose. Okay, so you can understand what we are doing. Uh, we can equalize the images. Okay, histogram. Now coming to one important, yes. Now I want to do some image imprinting. What is image imprinting? If I want to mix two images, if I want to, you all are aware that image steganography is there. Image steganography is a technique to hide as I uh, I can give example. Many persons are many master's thesis are related to this. Okay, hide watermarking, steganography. Okay, so steganography is a technique of hiding one image into another image. Okay, so just like that, what we are doing. We are mixing two images. Two images we are mixing. That is known as image imprinting. So how we will do image imprinting? So I am demonstrating you this. Okay, so here we are reading cv2.imread. First image is a B image, and dimension is 800, 800. Okay, and I am resizing image because dimension should be same. So cv2.resize. So cv2.resize is the size of resizing, and I'm giving this image and dimension. Dimension is 800, 800. Okay, so my image one is here with dimension 800, 800. Now I am capturing image 2. Image 2 name is A. First image I captured B, and second name is A. Read another image. So syntax is this. I'm again resizing this image cv2.resize. Okay, and dimension should be same, just like 800, 800. Both images should be of same dimension. So I'm putting dimension same for this image and for this image. Okay, now what I am doing, I am adding those images, add weighted. So by using this function, I can perform image imprinting. And I'm image, and this is a value, and this is a value. You can put. Okay, so time is not sufficient to explain these parameters. Okay, so do one and you can explore more. Okay, and if you have still doubt, then you can ask. I will share my mail ID also. Okay, so cv2.add weighted. Okay, so here one is 2. What this function is doing? This function is doing image, both image adding images and performing image imprinting, mixing both images. Okay, and the cv2.wait key. Why I'm doing this? I'm not giving a 0 second time. 0 second time. Save this image. I'm running this program. Yes. Now you can see. First image was there, B image and A image. Now, as you can see, I mixed both images. So this is a result of image imprinting with the help of software. There is a no single error is not here. Okay, what you are doing, you are mixing two images and without zero error. Okay, so this is a known as image imprinting. Everyone, you can see my screen. So this is example of image imprinting. So only simple, by writing simple lines. Earlier we were observing that MATLAB is very easy, but Python is very easy, easier than MATLAB, because for MATLAB you have to pay money. For Python you are not paying money and you are getting same result, same lines of code you are doing. Okay, so you can prefer MATLAB and Python also, but I have chosen Python. Okay, now coming to another example. Okay, yes, now another main example. Yes, I have an image. Okay, so I'm moving to this my presentation. Okay, yes, I have an image. Yes, yes, everyone, can you see my screen?
Yes, sir.
Oh, okay, okay. So this is all about whatever I covered. Okay, now I covered this also. Okay, now coming to this. Okay, now two images are there. Okay, so I am mixing these images. Okay, this is one image, open CV is another image, and background is another image. Okay, I want to mix those images. Okay, so what I have to do? So here what I am doing, I want to demonstrate you. Okay, okay, so first image is AB, normal background, and this OpenCV logo is there. So I'm reading this image AB. So for reading CV2.imread I am doing, and I'm storing inside IMG. I'm reading another image that is OpenCV logo. So this background is different. AB is a background, and this is a logo. Second image. Okay. Now what I am doing, I am getting the shape and color. Okay. Okay. Rows and columns I am getting. Rows and top left corner, rows 0 to, okay, region of interest I am getting 0 to rows and 0 to columns, how many rows I have and how many columns I have. So this is only for identifying top left corner. So this code is giving me a mask. Okay, so this is giving me a mask. Okay, now what I am doing, I am converting this IM2 image into gray image, because we perform processing in a gray image. Okay, then later on we convert. Okay, because gray image processing is a very efficient. Okay, because you are performing only one time, but you are doing color image processing, then it will take 3 more times, because it is a combination of red, green, and blue. So it will consume more spaces and more processing power. So CV2 dot. Now what I'm doing, I'm converting. Yes, I'm converting this image, then I'm converting into gray, then I'm performing bitwise not operation. Bitwise not operation I'm performing. Okay, so bitwise not operation for mask. Okay, and because I want to remove some area and I want to add some more area, so I am performing bitwise and operation. I am performing on these two images, ROI and ROI mask. Then let us see what's going on. Okay, so here when I perform bitwise operation, then this was one logo, this was another logo. So by using this I can put any logo on the screen. So this way I can do with the help of bitwise or operation. It's a different from image imprinting. Image imprinting, inside that we were mixing two images, and here I am putting at the top. Okay, right, you can take any background and you can write your name. You can take a logo of the company and you can put, for example, you want to make a greeting card, happy Holi, happy Diwali, okay, happy New Year. So take a logo and choose another background and perform this operation, then you can easily do this. Okay, so this is known as a bitwise and operation. Bitwise and operation we are performing. So this is the beauty of programming. Because the time is very limited, I wanted to cover so many things. Okay, so this is a very rich library. And last, yes, bitwise and operation we performed. Okay, on region of image 1 and image 2 mask. Okay, so everything I have explained. Now coming to last one more example. Yes, yes. This I want to find out ages. Okay. So here I am importing CV2, NumPy, Matplot Library. I am importing. I am reading the image. Then I am performing Kenny operation. Kenny filter is there on the image. Image I am performing Kenny operator, Kenny filtering, and I am performing a subplot. And in this subplot I am showing the image, and you can give name, gray, whatever you want, and you can get this kind of edges. So these edges you can get. This is any Kenny edge. Okay, Kenny edge detection method. So Bill, you can develop any more. Now coming to very important face detection. Face, how I can detect face. Okay, time is very limited. Okay, I have only 15 minutes time, and I have to cover a very important topic, face detection. So how I can detect a face? So I am importing NumPy as an NP. Everyone, can you see my screen? My screen is visible to
Yes,
all.
sir.
Yes, sir.
Yes, sir.
So I'm okay. So thank you. So I'm importing NumPy as an NP. I'm importing CV2. What I am doing here, I'm using cascade classifier. What is cascade classifier? You can make your own classifier. Okay. But what I am doing, I am using a XML file. Here I have already some databases there, and someone captured default code for face, how to recognize a face. So I'm using that XML file. You can create your XML file. You can start your web camera and you can capture your cascade classifier. You can make your own cascade classifier. Okay. So I'm using har cascade front face, default name is there, XML. Okay, this file I'm using. So I am giving this inside the face. So what this is doing, this is showing me face. This is only representing, this is a face, this is a face, this is a face only. It is containing the face information. This XML information, this XML I stored in the desktop. Inside desktop, the IP folder is there. Inside that I kept this, okay, and I'm using this. Okay. Now for eyes, someone has given IXML. What is the definition of eye? How eye looks like? Okay, so I'm using existing methods. Okay, you can use your own method. Okay, how to recognize cat's eye? So cat's eye XML package is there. You can use human eye. I'm using how to recognize dinosaur's eye. So for dinosaur's eyes size and your eye size is different. So different XML file will be there. Okay. So frankly speaking, I am using existing XML files for face and for eye. So this is a function cascade classifier. This is capturing this image and giving to face cascade variable. I am giving a name face cascade. And what I am doing here now, challenge comes. I have captured face. What is face and I have what is eye? I trained my system. What is face and what is eye? Now challenge is here. I am giving my image, but computer is not aware. Computer is not aware about RGK, who is Ram Kopal Kashyap. We don't know. But I am giving this image and I am saying, computer C, please detect face inside this picture. Now let us see how this XML file will help. Now I am taking this image and I am converting this image into gray form, gray color image. Now okay. Now yes. Now coming here. Yes. Now yes. Okay. Now face cascade. Face.cascade, I'm using this face cascade. Detect multi-scale, and I have given this parameter 1.3 and 5. Okay, these are variables. You can give any variables. Okay, you can adjust your window size. Okay, so I am giving this image and I am running some loops for my face. Rectangle should be there at the top, then move slightly, complete. It is measuring complete. This loop is measuring complete picture. Okay, now let us run. Yes, I'm running. I gave my face and okay, it will open. Yes, yes. Now you can see it is perfect. It is started from corner and it captures my eyes, nose, and face. You can see. So this is a face detection. Okay, You can give any face and that will recognize your properties. It is a cartoon picture. Okay, in this cartoon picture, my nose, one nose is clear, second nose is not clear. So computer is not able to recognize second nose. Okay, so this program was not for nose. This was only for face and eye. Okay, so now check. Is it capturing your face and eyes or not? So these kind of XML files are there. You can download, you can make your own XML file. You can give your face and you can detect faces. You can give your face. You can give your new meaning. Okay. So very important concepts are there. Many things I wanted to cover, but due to limitation of time, because only I'm getting reminder. Okay. There, okay, so I'm just moving to last slide. Okay, so yes, is it visible? Okay, so yes, now coming to image processing and machine learning. Yes, so machine learning is very important and the emerging area. So we can mix image processing and machine learning to classify image in a better way, and you can do your PhD thesis, okay, by combining image processing task and machine learning task. Okay, so there is the one picture, as you can see on the screen, and you're writing a command, and this image is given to you, and what you have to do, you have to classify the image. So you have to write a image machine. You have to capture. For capturing the image, you can use image processing. For basic operation, you can use image processing. You can resize. You can improve the quality. You can do histogram. You can equalize everything. Now you want to classify, because in machine learning also you have to classify. Random forest is there. Decision tree is there. So how we will classify? So for this code, I need 3 to 4 hours, but time is not there. So I'm only explaining you concept. Okay. So I want to perform machine learning task. So here, so from this image, I will extract animal data set. So animal data set I will take from image. So by image dimension, by putting a dot dimension, a dot size, a dot color, a dot height. Okay. By this I can get the features. Okay, so from image you can get features, and these features, for example, name of animal, tiger, size, color is yellow, height is 4 feet. Yes, very nice. These are extracted from image database. In image, everything was there, dimension was there, color was there, everything was there. Okay, so I have kept only these things. Okay, now yes, now machine learning. How I will perform machine learning? So I am giving color is equals to yellow. Computer, please identify images whose color are images. Now I am mixing image processing and machine learning. So it will process, machine learning algorithm will process these image data set, and it will pick color is yellow. Yes, color is yellow. Tiger belongs to yellow, and giraffe also belongs to yellow. Yes. Now it will show me, yes, color is yellow means tiger and giraffe. Okay. Now, but it's not a complete classification. It's not a complete classification. I classified an animal who belongs to color, whose color is yellow and whose color is not yellow. Not color means elephant, and here for deer, reddish brown was there. So color, it classifies into two cat sections. One, tiger and giraffe. Second, in elephant and deer. I will take only 2 minutes. Another 2 minutes. Okay. Okay. Thank you so much. So now coming to this, then again next image processing, we are applying machine learning. Okay. Now, with the help of this machine learning, we are able to classify, yes, color is yellow means tiger and giraffe, and no means elephant and deer. Now, another, apart from color, height should be less than 6 feet. Yes, this is the next command. Now, height less than 6 feet, tiger height was 5 feet or 4 feet, giraffe is more than 4 feet, 6 feet. Okay, and here you can see whose color is not yellow. Deer height is less than 6, and elephant height is more than 6. Okay, as you can see in data set. Okay, 19 feet height was there for 9, for giraffe, and for elephant 10. So it's a more than 6 feet. Okay, so this is a classification. For this, we can also write code. This is a random forest. This is a decision tree. But we are merging this image processing with the help of with the help of machine learning algorithms. So beauty of image processing will increase by mixing machine learning with the image processing. Okay. Now, thank you so much for patience listening. Okay, because time was the limitation, and I had to cover so many things. This is my contact number and mail ID. If you have any doubt, then you can mail me. You can contact me. Okay, thank you so much, sir. Okay, thank you. That's from my side, sir. Pratik, sir.
Okay,
Yes,
thank you, sir.
yes, ma'am.
Sir, can we move on to the question and answer session?
Yes, sure, ma'am. Please.
Okay, so I would request the participants to unmute yourself and ask the questions.
So my question, so thank you so much. It was a wonderful session. Sir, I want to ask, like, while giving the address of the image, you initialize it with R. Like before the path, you mentioned R.
Yes,
Can you
ma'am.
please explain R once again?
Yes, ma'am. Actually, when we give a normal path, na, then it will not consider any space. For example, you are giving a folder name image processing, and in that folder name there is a space between image and processing. So if you will give that path to this I am read, then it will give you error. Something is, it will not count spaces. For reading that history as a raw string, each and everything we would read, any parenthesis is there, any double quote is there. So for smooth reading, as it is reading, we are using R. So R is a raw string. Whatever you are giving, for example, we are giving a folder name image space processing, and once you are giving this path to this, then it will give you error. Okay, because there should be a continuation. For removing this error, we are giving a R code. Okay, so this is for R string. So it helps your time and your processing because it read your complete path. I hope I cleared your doubt, ma'am. Yes.
Yes, sir. Thank you.
Yes.
Is there anyone who is
Question?
having doubt?
Hello. Hello.
Yes.
Good afternoon, sir.
Yes, please. Yes,
Sir, good afternoon, sir. Sir, one term that you have
Yes,
used
sir.
in the program, that is RET. The term is RET, and it was explained that it is a Boolean variable that is going to hold either 0 or 1. Sir, is this a
Yes.
predefined variable? Is this a predefined variable?
Sir, you can give it any different name, but for returning value, we normal oftenly use this RET and frame. You can give your name. You can give your name, for example, Oriental. You can give. Okay, it will also work. Okay, so it's not a user defined. Okay, it takes only two variables. Uh, First variable is written. Okay, sometimes we get errors. That's why we are using a RET that is given by OpenCV. So we prefer this RET, but you can change. There is no predefined terms. And for frame, you can also give another name. For frame, you can give your name. But for easily identification, we give a relevant name for easy processing. Because in computer science, for example, in a variable name, for the variable name, I kept a name R, G, K. So it's a very difficult so that I can easily understand it is returning something. That's why I am writing RET. You can change.
But nowhere in the code RET is going to hold is either 0 or 1. So how do we come to know whether RET is a Boolean variable or not?
Okay, so RET, when we are reading now this syntax, now I am showing you. When
Yes.
we are reading this, so in this reading from this function, we are getting two types. Yes, yes.
Yes, sir.
Whenever
Why?
we capture this cap dot create, so
Yeah.
this video, when we are reading this video, then this is this from this video we can capture frames and we can capture written values. So these written values are is only showing your processor that video is coming. If this video value is going to 0, that means this value is not means this is not able to display you video. Okay, So this is only for your inner video processing. Okay, inner video processing. You are capturing images and some objects you are not getting. You are not able to. You have started your television and you are not able to watch anything. So you should get some kind of response from the processor. For that purpose, OpenCV has given this feature, and that is given inside the cap dot read.
Yeah,
Cap dot read. Yes. So you can change name of this return, and we are giving this return only to computer. Without this, computers also, yes, I agree. We are not showing you this return value and frame we are using, and return is only for computer purpose. Nowhere we are using this return, but computer is getting this value. Still I am alive or not, camera is working or not. So it's for internal processing.
So some internal processing is going on, or based on that
Yes,
internal processing, the
yes,
value is being held
yes,
by RET.
yes,
Okay,
yes. Because
so thank you so
yes.
much, sir. Thank you so much.
Any more question? Hello.
Hello. Yes, sir.
Yes.
Uh,
Is there any more question?
I guess new question is there. So I would like to request Professor Bhavna ma'am for the deliverance of the vote of thanks.
Thank you, Abhilasha ma'am, and good afternoon, everyone. I am Bhavna Sarkar on behalf of IT Department, Oriental Institute of Science and Technology. Extend a very hearty vote of thanks to our speaker, Dr. Ram Kopal Kashyap, who has given his valuable time. And thank you so much for making this session very interesting by giving various examples on how image is being processed and wonderful example of face detection. Thank you so much for making this session very meaningful and interesting. And I would also like to express a profound gratitude to our director, Dr. KJ Sudhakar sir, and our dean, Dr. Sanjeev Sharma sir, for his presence. And I would also like to thank our HOD as well as coordinator of this FDP, Professor Pratik Puchke sir, for his immense support and guidance. And I'm happy to express a vote of thanks to all the participants who are gathered together and make this session a very grand success.